Welcome to Study Loop.
Hello everyone, today we're doing chapter 29, problem 6, and this problem gives us this starting material and some sets of reagents. So first, it says that we're reacting this with a strong base, and then after that, we are going to react this with an aldehyde, and third, we are going to have some acid catalyzed and heat catalyzed hydrolysis. And that says what amino acid is going to be formed through this process. So if we can see here, right away we know that this base is going to dissociate into the metal ion and its conjugate counter ion, and we see that this ethoxide is going to be highly basic, and it's going to be able to rip off an acidic proton, being this alpha proton right here, giving us rise to a carb anion at this alpha carbon position, at which point this carb anion can then nucleophilically attack this aldehyde, making a bond. You make a bond, you break a bond, so this is going to make an O minus, in which when we add water, or this acidic water, we're going to have is spontaneous decarboxylation and hydrolysis to remove this ethanol, and to remove carbon dioxide and some more molecules of ethanol, as well as protonating this from O minus to OH. So at the end, what we see is that we'll be left with, if after step 3, we are going to lose this moiety as ethanol, we're going to lose this also as ethanol, and as well as carbon dioxide used through the use of this acidic water. So if you see, after step 1, what we're going to have is after step 1, we're going to have a carb anion. After step 2, that carb anion is going to be picking up an electrophile that we just added. Being this group. And after step 3, everything is going to get hydrolyzed off to give us our amino acid now. Which is this plus CO2 plus ethanol, ETOH. And particularly what we're left with is the amino acid serine. So you see here that this is the R group that we just added, and this is a serine amino acid.